Hello viewers, today we're going to cover the fuser in the printer repair basic series. I've laid out 3 here for you. We're going to cover a bit of theory. A fuser is basically a set of heated pressure rollers. After the image is printed and is on the paper, the fuser presses the image into the page with heated rollers that are non-stick and bond the toner particles to the paper. Depending on the brand and make and model, it's going to vary in the temperature at which these run. These are all roughly in the 200 degree-ish area. It's going to vary. It's going to vary based on what you print, what size paper you print. If you're printing whole 8x10 sheets, it's going to run hotter than if you print smaller sheets because it's trying to maintain a set temperature range. I'm going to talk about construction. So inside of a fuser, there's 2 sets of rollers. Both are non-stick. They're both heat resistant. Again, a fuser is going to get to 200 degrees. In this particular model, the orange roller is the one the heating element is in. On this one, it's going to be a light, a halogen bulb. On other models, like this one, there's actually a heated track of 2 heating elements that is laid flat inside the unit. Took the roller out of one so you could see it. So the roller is basically a silicone coating. The inside is just a hollow tube with a gear roll. It's going to be smooth. They're always smooth. If you ever come across a fuser and this isn't smooth, this is most likely where you're going to get wrinkling and page print defects. So the first time anytime I get a call and there's a printer defect, I pop the fuser out and I look at it. And I look for this roller to be smooth and clean, and also the lower roller, which I can show you on the one I've taken apart. This roller should also be smooth and clean. In there. So since we got it open now, since I've already taken this one apart for our viewing pleasure, let's separate it. There we go. So this is the heating element. It's a halogen bulb given full line voltage. Above it is the small thermostat that maintains the maximum temperature. If it were to overheat, this will open up and it'll turn this bulb off. And on these particular units, the actual tube just rides inside the plastic. They applied some heat-resistant grease there. So usually when you get a fuser issue, it's either this bulb didn't heat up or this bulb overheated. It's a lot of your fuser codes. Or one of the sensors is not reading appropriately. There's 2 sensors. There's this one, which is the thermostat, which basically breaks line voltage and turns the bulb on and off. Then there's this smaller sensor, this thermistor, and it's actually in contact with the outside of this roller. So what it's doing is it's measuring this temperature constantly. And it's going back to the computer inside of the printer itself, and it turns this roller on and off based on settings inside the printer and if it's getting too hot. So in all printers you're going to see usually a small control wire set for your low voltage for your thermistor, and a high voltage line set for the power for the bulb itself. And on the bulb itself, it's going to get its power from the low voltage power supply, which I'll cover in another video. Basically these just plug right in, and this provides the 120 volts to the bulb from the 120 volts coming in, and this is the low voltage that runs your printer. Then inside the printers, the fuser, the other issue you're going to get a lot of is fuser jamming. And fuser jams are one of those things because it's weird because they're all black plastic, so it's hard to see all the flags and all the flips inside. But let me bring you this one. Let me set this aside. I have this one, which I colored to make life easy for us. These small U-shaped parts here, these are optical sensors. Basically, a light is emitted from one side, it's received at the other. The small plastic, this black plastic flag, which I've colored yellow and white for you to see on the video, moves in and out, and when it's out of position like here, the light can go across showing it's open. When it's closed, it's blocked. So these are the flags. So as paper travels through the printer, it lifts these flags up and moves them out of position, and they move back and in and out. So when you get a jam situation, what you're actually looking for is this flag to be out of position, which is really common on these printers because people will pull the page out the wrong way and will actually get paper pieces caught in these little pockets. So now we're going to speak about jamming in the printer. It's not uncommon for the jam to be in the fuser. If you see a fuser jam, the first place you should look are what are called flags. They're these parts, these little arms. And then this one I painted yellow and white for us to see, but basically this arm moves out of position as the page goes through. When it comes back, this flag breaks this optical sensor, telling the printer that it has returned to its home position. Same with this one. There's 3 on this particular model. There's one here, here, and one in the center. On other models there's just going to be one, like on this one. There's one as the page comes by. And this one triggers a optical sensor that's still in the printer. So another problem is if you put in a new fuser and you get a paper jam, this arm may have not inserted correctly into the optical sensor. It's very common. One of the big problems you'll end up with these printers is someone will jam it and then they'll try to yank the paper out of it the wrong way around. So we will get some paper going on in this printer. As you see now, we've actuated both flags, so if you look carefully, I don't know if you can see it there, but this is open and that is open because there's paper inside the printer. Let's run this through a bit. And oh, we got a jam. The most common thing a user is going to do is they're going to go open the top of the printer, see this hanging, and they're just going to yank it out. And they're going to go, oh no, ah! And then, as a technician, I've seen that more times than I've ever wanted to talk about. But they're like, I don't see any paper in it anymore. Because they've now shredded the sheet. All the crap. That's why you always want to pull paper in the direction of travel of the printer. So in this case, I would take this out, roll this gear with my thumb, until the paper came to here where I could reach it, and simply remove it. The other thing you're going to get a lot of, let's see if I can't get it to do it. Always when you want them to break a specific way, it doesn't work out for you. Yeah, it sounds nice and crunchy. Is they'll yank their paper out. Yeah, there we go. Here we go. I don't want it to have happen. Nope. But typically what will happen is a paper will get caught underneath this flag and hold it up. It'll give you a constant paper jam, and no one can ever find it. So basically you go through and you check all the flags all through the printer, and you'll actually find the sheet caught inside. It's really common in these. There's not much else on a fuser that you have to really worry about. Roller condition, flag positions, and then, you know, tightness of turn. This one, as these get older, this doesn't rotate anymore, which is where you'll get a lot of the 4000 series. You get the swing plate problem is this gear gets tight, the motor drives it, and it tears the little plastic teeth off. It's a very common issue in your like 4000 series, your 600 series Enterprise. Other than that, they're pretty resilient. Most units have a replacement cycle way before these die. These are all out. All these fusers have been removed for preventative maintenance. This fuser has had 120 some odd thousand pages on it. Or, no. These are, I think, 500,000 or something of such a nature. These are high interval fuser rollers. And as you see, they're in great shape. You'll get some older models that don't have don't have maintenance counters, and these get just destroyed. I've seen paper wrap around these. I've seen all kinds of things. But if this roller is not in good condition, or the other one is not in good condition, you're going to end up with really weird things on your paper. Or if this coating wears out, you'll notice that an image can get picked up and then rolled and redeposited somewhere else. So you'll get this stamp that goes all the way down the paper. There's really nothing serviceable about these. We replace them as modules. And you can take them apart if you want to learn more. I highly recommend, if you want to learn more on fusers and the technology, is you get yourself the HP LaserJet 4345 multifunction printer manual, the service manual. It has all of the theory of operation of all the parts inside the printer. So if you want to learn about theory of operation. Okay, so as far as diagram go, this is the one out of that manual with theory of operation. But yeah, basically see, here's your fuser module, the sleeves, the pressure rollers, the heating elements, the thermistor, the thermoswitch. Then it shows its connection. But there's your low voltage power supply, DC controller, wall power coming in. Oh, the only other thing you need to know. these are voltage rated to your particular part of the country. So if you live in North America, 115 volts, you live somewhere else, 220 volts, whichever voltage you operate at, these operate at that line voltage. Because across this pair is line voltage. And then, if you ever get a fuse or error, and you can get to the low voltage power supply, you want to back probe these and make sure you have AC power at boot up, because this should preheat at some point during the boot. If it doesn't, there's a good chance either the bulb doesn't, if it gets power and it gives you an error, this bulb probably didn't heat. If it doesn't get power, you may want to look at your your low voltage controller board for damage. But as far as this section, I believe that covers everything you need to know about fusers. If I think of anything else, I'll make another video. Thank you guys.